Okay, we are going to talk about identifying functions today. So we have Miss Marily here with us. And I want to talk about this. I was saying it's my favorite thing to talk about when I teach GED. Like if I have any student who's about to test and they come into my office, they say, Kate, I'm about to take my math test. I always say, do you remember what a function is? And review this with them real quick. Because it's one of the few things that we can learn in algebra just in 5-10 minutes, and then you're most likely going to see it on your GED test. Plus, it'll come up in your college algebra classes. So let's go ahead and talk about functions. So first, I'm going to just define what a function is. And I'll give you a mathematical definition for it first, but then don't worry, I'll put it into English. Okay? A function is a relation in which each input variable has a lot of names. We often call this the independent variable. So that kind of sounds like science class. That's something we had to know for our GED science test. And in fact, this is very much related to science. But we also call that the independent variable, or sometimes we just call it X. Commonly, the independent variable is X. Not always, but a lot of times mathematicians use X for the independent variable. So a relation in which each input variable is mapped to one and only one output variable. And our output variable also goes by a couple of names. He's often called the dependent variable because the output depends on what you put in. The answer depends on what you put into the problem. So, oh, I can't spell. Or as we often know it as Y, okay? So a function is a relation in which each input variable is mapped to one and only one output variable. Now, let's start going through these words here to make sure we understand them. First of all, a relation. There are lots of different types of relations, but there's 4 big types of relations you're going to see on the GED. Maybe I should have said 5 because you can actually see word problems. Okay, so let's take a look. So you might see a relation in a equation. And what you're going to notice when it's in an equation form is that there's 2 letters. There's 2 letters. So for example, I might see the equation y equals 2x plus 7. This is an equation, but do you see how it has both an x and a y? Mm-hmm. That's why I'm calling it a relation. Those 2 things are related. You're like, well, what's x? Well, I don't know what x is. Well, what's y? Well, depends on what x is. So that's that idea there of y being a dependent variable. I'm saying whatever I make x, it's going to change y. So if x was 1, y would be one answer. If x was 12, y would be a different answer. Does that make sense to you? Mm-hmm. Okay, cool. So one type of relation we're going to see is an equation. Another type of relation that we might see is you know, I almost want to put this together because you know what? We can see a set of points in 2 different ways. So now I get to go back and change it to 4. Again, I keep changing my counting on you. But a set of points could come up on the GED. Now, we write sets of points different ways. One way you might see a set of points is like this. They'll open up set notation. That says the set. And then they'll list some points. And if you watched last Tuesday's class, you saw that points are in the form of open up a parentheses, you have an x value, comma, a y value, close parentheses. So there's 1 point in my set, and then you would just put a comma between all the other points. So there's another way I could make a relation. I could have a set of points. And so it's kind of like I have a bag with 3 points in it. So that's what I mean by a set. It's just like a holding container. Okay, so there you go. That's 3 points right there, a set of points. Is that good? Mm-hmm. It could have been 3 points, 12 points, 162 points, whatever. This isn't the only way you'll see a set of points, though. You could also see an XY table, a table. So if you see it in table form, though, it's the same thing. So I think I'll draw it. So, and I have my mouse today instead of my iPad, so you know that's always ugly when I draw that. But you could also see your relation, your set of points in a table form, where we call this a T-table frequently, where I have an X on one side and a Y on the other, and they give me some number in X and a number in Y. So that right there is the 0.23 or the 0.14. So just another way you might see a set of points being presented in a T-table. Does that make sense?
Mm-hmm.
Okay, cool. So we could see it in an equation. We could see it in a set of points. We could see it on a graph. Okay, so now we said that it was a relation. So if we're looking at a graph that's a relation, you're going to have both that x-axis and that y-axis that we learned about last class on our graph, because we're looking at how x is related to y. And then it'll have something drawn on the graph. It could be points, it could be a line, it could be a squiggle, it could be anything. Whatever is drawn on the graph is the graph. Okay, is that good?
Mm-hmm.
Okay, and then the last way, I just decided at the last minute to include that you could see a relation is in a word problem. But again, what you're going to see is you're going to see two related variables, two things that happen together. Let's see. So if you ever think of like when one thing changes, another thing changes, they're correlated. So great example, the more calories I eat, right? We're women, Marily, we're always thinking about calories, right?
Yeah.
The more calories I eat, the more weight I gain. Does that make sense? More
Yes.
calories, more weight gain.
Yes.
So I would say that calories and weight gain are a relation. They're related. Does that make sense?
Yes.
But not just that, right? The more that I exercise, the more weight I lose in theory, although it's not working out for me, sister. But anyway, the more I exercise, right, I might see that related to weight loss. Now, you and I can argue all day long if that's a very strong relation or not, but they are definitely related. Okay, does that make sense to you?
Yes.
Okay, so that's that idea of related variables. Okay, so that is what I mean when I say a relation. So any one of these can be a relation. Now, notice, I didn't just tell you that a function is a relation. I told you that it's a specific kind of relation, a specific kind of relation. I said it's one in which each input variable is mapped to one and only one output variable. Each x only gets one y. Or each time you put a number into your function, you get the same answer, okay? So students are usually confused by this because we're totally used to math behaving like this. For example, if I had the function add 3, no matter what number I put into add 3, like I say, okay, I'm going to take 5. I'll start with 5 and add 3. I'll get 8, right? It's not suddenly going to change the next day. Like the next day I put 5 into the plus 3 function, I don't get 11. I always get 8. I always get the same answer. Does that make sense?
Yes.
Okay, so this is the way that I sum up a function. You can tell something's a function if the x is faithful. And this is just Kate language now, not math language. But I'll show you what I mean. This is my shortcut way of thinking of this. If the x is faithful. Okay, let's go do a bunch of example problems so I can show you what I mean, okay?
Okay.
Did you get this page down?
Yes.
Okay. It's okay. So I'm going to look at number 1 here. It says determine if each relation described in the table is a function. So I told you it's a function if each x value, like here's an x value of 2, is mapped to one and only one y value. So you're looking for your x's to be faithful. Now, this very first graph is a great example of something that's not a function. Okay, let's take a look here. Oh, that's not what I wanted. There we go. Okay, so here we have a 2 that's being mapped to a 7, but we have another 2 down here. See, I have an input of 2, and look, this time it's mapped to a
4.
4. Yeah, what we have here is we have this little cheating 2. Sometimes this 2 is mapped to a 7. Sometimes this 2 is mapped to a 4. The x is not faithful, and so this is not a function.
Okay.
So I would probably just say like, no, not a function. Because I said determine if each relation described in the table is a function. I'm going to say not a function.
Okay.
Okay, so now let's take a look at this one. Now look here. On this particular problem, we have 4 mapped to -3. Then the next one is a 5 mapped to -2, and a 6, and a 7, and an 8. Do you see how none of my x's repeat?
Mm-hmm.
So each one is its own answer. Each one is its own problem. This is definitely a function. Now students get mad at me all the time. They say, Kate, how could that be a function? And they really do, because they look over here at the y. Did you happen to look at the y over here and see this?
Yes, that minus the, how do you say it? Yeah, the -3, -2.
Yeah, and they're like, hey, look, we have repeating y's. How can this be a function? You know, and just like the world, I joke around, it's a total double standard. The x's have to be faithful, but they don't care if the y's repeat. Nobody cares. Okay, so don't worry about repeats in that column. Only worry about repeats in the x column, okay? So now let's take a look at this next one. Do you see any repeating x's?
Yes.
Oh no, you caught them cheating. Where did you see a repeating x?
1.
Exactly. Here we see 1 mapped to 5, and then just a little while later, oh, but look what 1's mapped to.
To 5.
What is it mapped to? Is it mapped to a different number?
To 5.
It's mapped to a 5. It's mapped to the same number. Ooh, they tried to trick you here.
Mm.
I didn't even realize that was there. I'm glad we talked about it. So usually I'd be saying not a function, but take a look. We said it was only, it's a function as long as each x is mapped to one and only one y. And we can see here, even though x repeats, both times it's at the same y. Somebody just accidentally wrote this number twice in this problem, so it is still a function. Does that make sense?
Okay, yes.
Okay, cool. I was about to tell you it wasn't a function until I circled them. Okay, so help me out with the next one. Do you see any x's that are cheating?
They're all repeating.
And cheating. Yeah, say it again.
They're all repeating.
Exactly. Look at this. -3s with 4, and then -3s with 3, and then no wonder he's your ex, huh? All the y's. Okay, so that's definitely not a faithful x, and so we definitely don't have a function there. No trick at all. Can I just say not a funk, since I'm out of line? We got funks and not funks. Okay, so then now let's take a look at the next one. So what do you think about the next one? Function or not a function?
Not a function.
Ah, good. So this is the thing that trips up everybody. They ask me all the time is, they'll ask me, what about 2 and -2? Aren't those the same number? And you and I know those are not the same number.
Mm-hmm.
And so you're right. That one is a function. I have all different x's, and who cares that they're all seeing the same y? The total double standard. It's only our x's that have to be faithful. So that sure is a function. Is that good?
Yes.
Okay, sweet. So now, we said that our relations could show up in tables, our sets of points, but sets of points can also show up in that set notation. And so down here we see some ones in set notation. So as we're doing these, please remember the order in points. Do you remember which one was the x and which one was the y? Or did you get a chance to watch the last video, Merle?
I did watch it, but I do not remember.
Okay, it goes in alpha order in a point. That's how I remember it. So it's x comma y. So this first, oh, that's ugly. So this first, like on this one, this first 2 is the x, and this next one is the
Y.
y. So as we're looking to see if the x's are repeating, we'll come through and examine all our x's. And that's what my eyeballs are doing to see if this is a function. So what do you think, function or not a function?
Not a function.
Not a function. Look at those little cheating 2's. I got the same x here, 2 and 2, saying 2 different numbers, 2 and 4. Same thing there, -2's cheating too. Okay, so again, let's do one more like that. So here we go. We're going to again examine our x's. So there's a 1, a 2. What do you think? Function or not a function?
A function.
I absolutely, yeah. Do you see what I did wrong? And you didn't even correct me, really, because you're too sweet.
Non-function.
Like, okay, Kate. Which one? Tell the whole world so the whole internet can hear you correct me.
Non-function.
Yeah, which one was not a function?
The first one.
The first one. Thank you. Land, Kate's in trouble. I say one thing and I write another, y'all. Can we blame this on my ADHD? What do you think? I'm like, my brain and my hand are having a fight. Okay. I also have all these lovely fans on the internet who I'm so glad they watch my videos. But it's very humbling when they correct my math. Okay. So let's look at the next one. We want to see if it's a function or not a function. What do you think?
It's a function.
I absolutely agree with you. When I scan through these x's, I don't see any repeating x's, so no chance for cheating at all. And you're right, that is a function. Very nice. And I'm going to even type it correctly, because how many times can I screw up in one day? Okay, excellent. Okay, let's just do one more. How about D? What do you think on there? Function or not a function?
Not a function.
Not a function. Justify your opinion for me as I type it correctly. That's not a function.
The zeros are all repeating.
Exactly. Look at those X zeros repeating, seeing all these different Y's. Okay, great. So now let us look. Okay, let's look at some graphs. So we said we could see relations on graphs too, which means we could test if a graph was a function. So now the interesting thing about a graph is it's hard to tell the individual X's and Y's. Students kind of struggle with that concept. So I think before we actually start one of these problems, let's look at 2 of these that you told me were functions and were not functions, and let's take a look at their graphs, okay? So let's see. Let's look at B here, okay? So you had told me on number 2 that B was a function, correct?
Mm-hmm.
Okay, I want to take a look at what happens if I were to put those points on a graph. Okay, now realize that I'm just sketching, so it's not going to be a perfect graph, but let's give it a try because I want to show you something that happens. So hopefully we'll watch the last video so that we can do this. The first point is what point, Merle? In B. What is the first point you see here?
1x and 2y.
Exactly. The point 1, 2. And so I'll come 1 in the horizontal direction, the x direction, and then I'll go up 2. And it's about right here. You good with that?
Yes.
Okay. Next point is?
2x and 3y.
Okay, so I'll go over 2 and I'll go up 3, about there. Good. And next point we see?
5x and -1y.
Good, so I'll come over 5 and then I'll go down 1 this time. Okay, so that's good. And now this next one, -2, 3. So I'll go back 2, up 3. And our last point, -1, 2. And I promise I'm doing this for a reason. Negative 1, 2. I want to show you guys something. Now, let's compare that one that we said was a function. So that one's fun. Fun functions. You can tell it's the end of the day. Okay, let's compare it with one that you said was not a function. Give me one of these again that's not a function, Marley.
The first one.
The first one. Ooh, that's a good one. I want to look at that one. Oh, let's do it on the same graph with a different color. So I can really show you this. Okay, so let's try this. If I had the point 2, 2, it'd be about there. Yeah? 1, 2, 1, 2, right there. Is that good? Now, tell me what point that didn't work with 2, 2. Which one made it not a function with if you have 2, 2 in the same relation?
2, 4.
Exactly. So let's look at 2, 4. So I'm going again. I have the same x. 1, 2, and then I go up 1, 2, 3, 4. I have a question for you. What do you notice about these 2 green points?
They're in the same direction.
Yeah, they sure look, they're like lined up, aren't they? Let's try it with the other 2 since we had another 2 that were like cheating. The negative 2s. Let's try it. So if I had a negative 2, 7, I don't know, it'd be like about maybe here. I had to go off my graph. Does that look good to you?
Mm-hmm.
So I went back 2 and up 7. And then if I went back 2 and up 9, so back 2 and up 9, maybe I'd be about there. How's your assumption? Did those 2 points work out the same way?
Yeah, they're the
Yeah,
same.
they sure did. They ended up on the same line. Okay. So now that we discovered it for ourselves, I can tell you the test that we do to test if a graph is a line. So this is important. Write this in your notes. You will hear your college professors talk about this. Okay. To test if a graph is a function, use a vertical line test. What kind of line? We saw that when points had the same x, they stacked up on top of each other in a vertical line, right? And so we are going to use a vertical line test. We are going to drag a vertical line across our graph and see if we can ever catch more than 1 point. So like here's a vertical line. And if you look at that, you can see I'm only hitting my graph at 1 point. Can you see that?
Mm-hmm.
Okay, let's try again. Anywhere on the graph you could draw a vertical line. Here, I'm only hitting it at 1 point. Here, if I drag a vertical line, I'm not hitting my graph at all.
Mm-hmm.
Here, I'm only hitting 1 point. Here, I'm only hitting 1 point. In fact, no matter where I draw a vertical line on this graph, I'm only going to hit 1 point. That means I have a nice, faithful function.
Mm-hmm.
This is a function. Now let's go find a graph that fails a vertical line test.
Okay.
What did you say?
Okay. I said okay.
Oh. I thought you were telling me which graph to go to, and I was like, really? Awesome. Okay, so I found one that I drew 1 vertical line and it already failed. Can you see that this guy, when I drew this vertical line, I crossed my graph in more than 1 place.
Mm-hmm.
Can you see that?
Yes.
That is a fail. The second you can find any vertical line that crosses the graph in more than 1 place, we caught an X cheating. Your graph failed the function test. This is not a function.
Mm-hmm.
Does that make sense?
Yes.
Okay, cool. So let's take a look here then, and you're going to tell me because the graphs are the hardest for most people. So look at this second graph for me in between these 2. If I were to drag some vertical lines across this, what do you think? Could I catch this graph cheating anywhere?
No.
No, you're right. This is a super faithful graph. It's faithful on every single vertical line, no matter where I draw it. And indeed, this is a function, nice, faithful function. Does that make sense?
Yeah.
How about here? What do you think? Can I catch this graph cheating anywhere?
No.
No, take a look here though.
Oh, you are smart.
Yeah, can you see it? When I
Yeah.
drag that vertical line, don't I catch my circle here?
Mm-hmm.
Yeah, I catch my circle here and I catch my circle there. I caught an X cheating. Guess what?
Mm-hmm. Not a function.
Not a function. I got like every color of the rainbow here. Okay, so now this one's a really good one. I like this example because students don't know what to make of this point right here. So right away, a lot of students will say, hey, look, I have a vertical line right here, and I'm not sure if I caught 2 points or not. Did I catch 2 points? You know, this one's black and this one's white. Does it make a difference? And the answer is yeah. It does make a difference. So let's talk about those when a point is black and when a point is white like that. Okay, so when a point is black, it's filled in. That means the point is included. Okay, but when a point is open like this, do you see how it's a light circle and it's open in the middle?
Mm-hmm. Yes.
Okay, that means that that point is not included in the graph. Our graph goes up to that point, but does not include that point. We can get every value right before it, but not that point. Does that make sense?
Oh, yeah.
Okay, wonderful. So if that's the only place on this whole graph I can catch more than 1 point, but yet this one's included, that one's not included. So no problem here. This still is a function. That was a tricky problem. Is that cool?
Yes.
Okay, so let's look at the next one. The next graph is just consists of some points. What do you think, function or not a function?
Not a function.
Not a function. I agree with you. Where's the point you see cheating? You tell me.
The second one on the right.
Exactly. Those two little stacked up points there on the right break that faithful function rule, and so this is not a function. Second, you find a rule breaker, not a function. Good. How about the next one? What you think?
It's a function.
It sure is. And the last one, tricky, tricky.
It's not a function.
Where do you see a place that I could draw a line and catch more than 1 point?
Sideways?
Oh, but there has to be a vertical line. So you're thinking like this, yeah?
Yeah.
Oh, good. I'm glad you said that. That's a different test for a different thing. For functions, you only use vertical tests.
Okay.
Later in math, when you're in college math, you'll learn a horizontal line test. It tests for something else. Only vertical lines for functions because we only care about x's repeating. Does that make sense?
Yes, it does.
Okay, so then do you change your mind then, or do you still feel the same? Is this a function or not a function?
I'm kind of confused with this one.
Oh, good. So let's check it out then. Let's draw some lines. I'm just going to draw like a bunch of vertical lines. How many points on my graph did I catch there? Can you tell? See how my graph just crosses it at 1 point, yeah?
Yeah.
I'll draw it over here. Just 1 point. Can you see it right there?
Mm-hmm.
I feel like I should be like drawing this for everybody. 1 point right there, 1 point right there, 1 point right there when I cross with that. So it seems like no matter where I draw my line, I'm only going to catch it at 1 point. So even though this is a funny shaped graph, it's called a parabola, by the way, it still is a faithful function. Can you see that? Does that make sense?
Yes. Mm-hmm.
Sweet. Good, 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 good. Wonderful. And let's look at some typical GED style tricks. Oh, I'm not going to do number 4. Yay, it's not on the GED. Okay, so let's look at number 5. Number 5 says, none of the following relations are functions. Put an x through a point that could be removed in order to make a function. So all of these have a problem point, at least one. Let's cross off the problem point so that we can force these guys to be functions. Make sense?
Okay.
Okay. So first one, let's take a look. I look at A. They're telling me A is not a function. Do you see the reason why it's not a function?
It repeats 1.
Exactly. And so I don't care which one of those you cross off. It doesn't matter. You could cross off the first one. That's not how, though. I'm learning how to use this mouse again every time. Okay, you could cross off the first one. You could cross off the second one. It doesn't matter. Okay, I'll cross off the first one. Who cares? And now it's a function. I took that point away. It's a function. Is that good?
Yes.
So take a look at number 2. Do you see the problem points?
Repeats 4.
Exactly. Which one you want to cross off?
The first one.
Sure. It doesn't matter, but it doesn't matter. She's like, the first one, is that going to be okay? Either one. Okay. Take a look at C. Do you see the problem points?
The second one on the right.
Yeah, those little stacked guys. And so we could cross off either one. I'll cross off that one. Okay, cool. Take a look at graph D. Do you see the problem points?
In the middle.
Absolutely. And again, you could cross off either one. It doesn't matter. Okay, cool. How about E?
The number 3.
Exactly. And again, you could cross off either one. I don't care. And then how about F?
1.
Exactly. And so I'll take off that guy where the ones repeat. Beautiful. Catching on so quickly. Okay. Last one. So number 6 says, circle any of the following points that could be added to the graph. So we're going to add points to the graph this time, but we want to make sure that when we add, it still represents a function. So let's take a look here. Can I add the point 1, 4? Well, I don't know. Let's go see where 1, 4 would take me. So 1 over, right? That's an x1, and 4 up would put me right here. What do you think? Can I have that point?
Yeah.
Yeah, I sure can. So I'll circle that. Oh, no, not like that, though. This is like watch Kate learn how to use a computer class. Okay, next one. So next one, the point 2, 3. So you tell me, how do I get to 2, 3 from the origin, Miss Murley?
From the bottom, the right 2.
Right 2.
And the top 3.
Up 3.
It would not be a function.
I can't have that one. You're absolutely right. I cannot have that point. It lines up with the point V, and so I may not have it. No, none of that. Okay, next one. Tell me how to get to -1, 4 from the origin, please, Murley.
From the -1 from the bottom.
You want me to go down 1?
I think it's down.
Careful. My first value is my X value, so that's my left or right. So should I go left or right?
Sorry, it's right.
There we go. Right 1. And then?
The 4 on the top.
4 up. Good.
But it wouldn't be a function.
You're right. I can't have that one. Nice. So I'm going to X that guy out. X that guy out. Okay. So the next one, help me out how to get, why am I circling it? Don't circle it, Kate. Okay, help me out. How can I get to that one?
It's the last 5 on the left.
Okay, go left 5.
And then up to the number 3.
Up 3. Beautiful. Can I have that one?
Yes.
Yes. Thank you. Thank you. So I'm going to circle D. Okay. Help me get to point E for me, Miss Murley.
3. Number 3 on the top.
You want me to go up 3?
I'm sorry, on the bottom.
Okay, so right 3.
Right. Yeah. And to 5 on the top.
5 up. Good. May I have that point?
Yeah. No.
No. Murley says no. Cut off, Kate. So I can't have that one because it lines up with point X. That would make me not a function. Okay. And last one. Help me get to the point -2, -4.
-2 on the left.
Good.
And -4 on the bottom.
Good. Left 4, down 4. And I have this point. Can I have it?
Yes.
Thank you. It doesn't line up with anybody. It's safe. Perfect. Perfect. Cool. That's as hard as they get on the GED. Congrats. I think you're prepped. 1 or 2 more questions right. Ready to pass our math. Excellent. Do you have any questions about this topic, Miss Murley?
It was really easy.
Right, isn't it? I know, I love it. Okay, so I'll be posting this in our online class, and for you other viewers, I'll be putting it on YouTube with practice problems so you guys can try it yourself. And happy studying. All right,
Bye.
bye.